Welcome to Data Science DC! Thank you for leaving the air-conditioned halls. Okay. So we got two short-ish talks for you today. We have Alice Long talking about using LLM Embeddings for a dating app, and we have Marck Vaisman who's going to complain about using Python as an art user. We're all very curious. Okay, so just some introductory stuff about the group and everything else. This is us. We are part of the broader data community DC community, which fills out task forms. There's a whole nonprofit, like the whole thing that Will runs, and I'm glad I don't have to. We have a number of other groups under that. So there's Data Viz, there's Generative AI, there's all these other groups. If you're thinking, oh no, she doesn't mean me, I do actually. If this is something you're interested in, all it takes is enthusiasm, a small amount of work, and being reasonably organized. Come talk to me or Janet or Jeff or any of the other people who organize these things in the room, and we will talk to you about it. dc2.org, Data Community DC on all these other places. Okay, thank you so much to our organizational sponsor, Rotational Labs. Woo! Yay! Okay. They help organizations build and deploy domain-specific LLMs, AI-driven data products. If you want to get in touch with Prima, you can send her a call. This is her info. She shows up sometimes also, so you can come back and get to meet her, etc. Okay. Sorry, this is from last time. But I guess also, okay, so big thanks to Excella, who hosts us and feeds us. Okay, so the organizers, Janet, Jeff, and myself, we're all on the internet. You can find us at various places. Okay, diversity statement. Data community C believes that diverse communities are better and stronger. This is also that our code of conduct are at dc2.org. Upcoming events. These are ours, and then we'll do community announcements and your upcoming events. So August 20th, we're writing a data book. There's a panel discussion of various people who've written books, data things.
Has anybody here written a book? Couple heads nodding, thanks for that. If you want to also be on this panel, just send me a message, all right? And we will make it happen. We're going to have some people here. Everyone can kind of just ask, hey, what's it like? And all the things. And we can talk about it. Cool? All right, just hit me up. We got the info. If you can't find it there, it's on Meetup. Just go to Meetup and find me there. I'm Jeff. Thank you.
Hi, Jeff.
October 29th in Georgetown. I've not sent the email about this yet, but it is up on the site. We're having a data happy hour. It was fun last year. It'll be fun again this year. We'll be joined by various other data groups, and there's our and Friends conference in town. They will also be with us. It'll be fun. Okay, your upcoming events.
Hello, everyone.
Hello.
Hi, I'm Mary. I am an organizer for Women and Gender Expansive Coders DC, or WGXC, which is a lot easier to say. We are having a bunch of events that we're planning, but we have one interested. How we just hang out, talk about problems. Check it out. It's on our meetup. Come find me again.
Sweet.
Awesome. Other upcoming events. This usually doesn't happen. Okay. Yeah, good.
I'm Small Stokes. I'm one of the organizers for Data Visualization DC. We're having a happy hour on Thursday in Roslyn, so please come to attend that. And then we're also having a monthly meeting August 8th, where we're organizing speakers for that now. So check us out on Meetup.
Sweet. Thank you.
Okay, community announcements. So one of the important functions of this group is helping people find jobs / advertise for jobs. So if you are in either of those groups, or if you have some other general community announcements, raise your hand, I'll call you, stand up, and tell us who you are and what you're looking for.
Hi guys, my name's Tony, and I graduated with a master's degree in physics not too long ago, and so through my academic background, I have a lot of experience applying in physics research and going out of school and transitioning into industry. I would love to keep doing data science and keep doing machine learning. So if you know of any entry-level data scientists or entry-level data analyst positions, please do let me know. Thank you.
Cool.
Hey guys, I'm Wayne. I run XModel or maintain XModel open source LLM fine-tuning framework. We're hiring machine learning engineer, high-torsion engineer, food engineer. If you fit one of those 3 buckets, hit me up. Or if you feel like contributing for free, hit me up.
Wait, I have a question. If we contribute for free, do we get swag?
I will, yes.
Right answer. Right answer. Okay. Other folks?
Hi, my name is Christina. Actually, I lost my job 6 months ago. I was the executive director for director of data analytics. I teach data scientist, data engineer. I was working with when I lost my job. So I'm looking for opportunity. I have 2 PhD, one of them AI, one of them data analytics. I have master 2 master's degree in engineering. Anyway, so if you have something in AI or cyber over AI, I'm really appreciated to reach out so I can work with you guys.
Anybody else? And we could have other community announcements that are not specifically job related, although those are always good. Anybody got anything else before we move on? Okay, cool. Thank you for attending and thank you for being part of our community. And that is another thing that should probably not be as but that's okay. Okay.
Hey everybody.
No.
Yep. I'm actually really curious about the second talk as well. Hot take. I don't want to start any fights, but like complaining about Python from a JavaScript user's perspective. Like our whole stack is JavaScript, except for the frickin' machine learning, and they don't know how to write code. Anyways. All right. Cool. All right. I'm Alex Long, and I'm talking to you today about LLM embeddings for a news-based dating app. I also want to preface that we also have a friends mode, so if you are already in a relationship, you could still be a user of our app. Just starting off with that. So who I am, I graduated from GMU in 2016. I've done a random mix of full stack development with some machine learning mixed in, cybersecurity. Worked with some big companies as well as startups, and now the co-founder and CTO of InPress. That's me glaring into the sun and trying to look at Kat's garden. Girlfriend, maybe the girlfriend should have been developing that. Especially because she's here. So I don't know. I'm also taking credit because this is Denny Jaban, who is our data scientist, and he's crushing it. He's done most of the work. I have been the sounding board and kind of the person talking with him, so I feel somewhat qualified to talk about his work, but definitely want to give him credit. Quick outline. I want to do a quick crash course on embeddings. I don't know if this is going to be helpful. It actually seems like this is a pretty technical group, but figured I would do that. Talk a little bit about InPress, and then get into specifically how that relates to our work. Embeddings relates to our work. So actually, quick show of hands, who has worked with embeddings either now or in a project, like personal project? Okay. Okay, great. Well, so actually maybe this is valuable. Yeah. So did this with cute clip art, so I'm not trying to be condescending at all. But I didn't want to waste your time and giving you an answer that you could ask ChatGPT. So I just asked ChatGPT. It gave me an answer that was kind of technical. I sort of liked what it said, translating words into coordinates in space. It's a good idea. So if you imagine a physical space like latitude, longitude, altitude, those are 3 dimensions. Embeddings have a lot more, but it's the same idea. It's a space. To give a very basic example here, if you only had 1 dimension, right, and you put the word mouse and the word elephant, you were trying to locate them on this 1-dimensional embedding, you might put them far apart because the concepts are relatively different, especially if that 1-dimension word represents the size of the object. This is totally arbitrary. And then other things like humans, axolotls. If you were to expand the embedding to a second dimension, maybe lifespan, then you would see points go to different points. So humans go up there. I don't know what's going on with the axolotl, but you would see them going to different points. And the idea with an embedding that a large language model uses is that it has these different dimensions. This is 2 dimensions now, but they're not human defined. So it's not, it's not lifespan, it's not size of the thing. The important thing is that they're maintaining the distance between the concepts. So mouse and elephant should be relatively far apart. It doesn't matter what the specific dimensions mean. And if we were to zoom out, we would hope that the dimensions are preserved, or the distances are preserved, as we bring in more and more distant concepts. So the word mouse and the word elephant are more similar than the word physics. So they might be relatively close together compared to the word physics. Hopefully this is somewhat intuitive. And so the idea is this would be a 3-dimensional picture, but embeddings, modern embeddings have thousands of dimensions. And the important thing is these dimensions allow them to preserve these distances between concepts. The really cool thing with large language models, and this has been around for a while, if you're familiar with dot-to-vec or word-to-vec, these were the kind of like older school things. The really cool thing with large language models, one cool thing, is that they can take any kind of input. There's supposed to be a picture there. Imagine a picture of it. I swear there's a picture on my screen. Imagine a picture of a news article. It would be much cooler. So imagine if there was a news article about Ariana Grande starring in the Wicked film. So the idea is you could take that whole news article, all the text that's in it, and pass it through the same process through an LLM to create an embedding that you would pass through the word axolotl or the word elephant. And you would just get this one point in space, and that one point represents the article. So the cool thing is you can take that whole document and represent it in the same space that you can represent a single word or a phrase. And so if you were to take that article and represent it in a space and also embed just the literal word music, you might find that they're kind of far apart because, sure, there's some relations, but like there's a lot more to Ariana Grande being in Wicked than music. But again, similar to the elephant and the mouse, you would hope that the distances are preserved. So again, if we brought in a very different kind of word, like physics, you would hope that those 2 points would be relatively close together compared to some distant idea. All of this is building up to how InPress uses news articles, but I just kind of wanted to give this preface. So quick detour from technical stuff. Beginning of this year, I was an entrepreneur with not a lot of direction in my life, you could say. And credit to Abby, my girlfriend, got me onto Y Combinator co-founder matching, where I met someone, Adam, who was making a news-based dating app. We had a great interview, and there was a beautiful picture of Puerto Rico, which is not right. But he said, actually, you're great, but we can't take you. You don't have those technical skills. I wonder if my next picture is going to reflect.
Probably the internet. Sometimes.
That's a good point.
Oh.
There you go! Wait, let's go back.
Yeah.
So, okay, beautiful Puerto Rico picture. Got this email saying, okay, sorry, we can't accept you. I had just listened to a video from Tony Robbins. I don't know if people are familiar with Tony Robbins at all, but I was a little pumped. And so I sent back this response where I was like, give me 1 month to prove it, prove that I can do the job. And they said yes. And so, long story short, I am now the CTO and co-founder of InPress, picture loaded. That's me and Adam at a Georgetown gala that we actually did promoting this earlier this year. Woo! Thank you.
Yeah.
So, okay, I'm going to dive into how InPress works really quickly, just so you have a sense of the context of the technical background. So this is the interface. So the first screen that you would see is the news feed. So users are actually reading news articles in the app. And then they are rating, there's different ratings. So in this screen, they're rating their feelings about it. And then you can also rate how important it is to you, how much you agree, how interesting it is. And then the final screen would be sort of the thing you're used to seeing, which would be, we're calling it the leads, but it's the recommended users based on the ratings that you've given. So that's the basic UI of it, and the goal is kind of these magic moments where, I don't know if anyone has had this, Actually, show of hands, who's on a dating app right now? Or in the last week? Okay, well, there's a new one coming to town, so get on that. So, it's coming up. It's coming up. So, well, hopefully people have had this experience where you see someone cool on a dating app. I had this experience. Yeah, I think Abby's profile said she was into avocados, acrobatics, and AI, or something like that. And so we're trying to create these magic moments where you find someone who has these really interesting niche interests. In general, I think research does show that like people can be pretty different, but having just a few things in common actually is like really useful for people forming bonds together. So that intuition is going to inform our algorithm going forward. One challenge that we have from other dating apps and recommender systems, I think I can go back to the full screen now, so more pictures. Right. One challenge we have is that we don't have a symmetric input and output. Most recommender systems, like Netflix, the input is the same as what the output is. So they're looking at what movies you've watched, and then they're trying to recommend what movies will you watch or do you want to watch. Tinder or other dating apps are looking at the people that you've swiped on, and then they're trying to predict who would you swipe on next. So we have an asymmetric situation here where we're looking at news articles that you've read and rated, and then we're trying to recommend people. So that's a slightly different situation that we have. And one part of the reason why this is kind of the perfect time for InPress is the LLM embeddings are great for analyzing news articles. The high dimensionality, so I was talking about like thousands of dimensions, that allows you to capture a lot of rich context, and that allows you to do the things where an article of Ariana Grande looks similar to the word music. And I'll get into the specifics of that in a bit. In general, they're high quality because they are trained on everything on the internet, and they tend to be pretty scalable. The OpenAI API is really cheap. I don't know if people have used it, but it's very cheap, it's fast, so we can run through thousands of news articles, just run them through the API and get the embedding back and store it all in the database, and it happens in a matter of seconds. So all of that is great for us. It's also, as I mentioned before, good for a variety of inputs, because you can take in these news articles as well as specific topics that people are interested in, and even specific entities. So you could look at like Taylor Swift, and you can see how that matches to a news article within the same embedding space. So, getting into the nitty-gritty a little bit. So, how we calculate leads, which are, again, the recommended matches that we're showing to people. The first step is that we're embedding users' articles. So, all the news articles that you've rated, we run them through, well, actually, we've already done this, but we take the embeddings, and the encoder in this situation is OpenAI. And so it's producing these embeddings, which are represented by numbers. Each number is a dimension, where it is in that space. So we're getting those embeddings. We are then clustering them. Let's see if I can. Okay. So then we're clustering the articles that you've read. So you can see here, we've got like the League and Arsenal are sports. I'm not a big sports person, but I believe those are sports. I believe those are soccer. We've got emissions, gas. We've got some political things, Trump, some tech stuff, and like music. So we're clustering the articles that you've read. We use this, let's see, so we're actually, I don't know what's not hearing, but in order to cluster them, we're actually reducing the dimensionality first, because it's actually really hard to do it in thousands of dimensions. And then we are using something called HDB scan, which is hierarchical deep scan. So the reason, I don't need to know about the technical parts of this, but the reason it's important is because we don't want to just match people on you like sports. We want to match you on you like, the League, or you like Ariana Grande, if you do. We want to find those very specific things. So we want to be able to capture the hierarchy of people's interests. So that's the advantage of using this clustering approach, is that you don't have to tell it how many clusters you want or how big the clusters need to be. So it can capture very small ones if they are dense enough and sort of represent themselves. Yeah, go for it.
So I know DB-Scan also has variable cluster size. Is that also, I'm sorry, variable cluster number? Is that also important? Like, do you do kind of like online learning and vary the number and attributes of the clusters as new circles come in?
Yeah, so the question is sort of like a little bit of sort of the hyperparameter tuning of DB-Scan of like, do you decide how many clusters there are and like, do you tune that over time? At this point, no, we're in a really early stage. That's certainly something that we're gonna consider, but honestly, yeah, we are trying to get this thing to market very quickly and trying to get something out the door that works vaguely well. So we are choosing hyperparameters that seem to work in our beta testing, and then we are shipping those hyperparameters. Yeah. Okay, so we've got, if you imagine all these dots are articles, the colored dots, and they're colored based on the cluster that we've determined them to be in. Then we would pick the centroid, which is just the weighted center of it. We use a little bit of a hack here, so if someone rates an article as like very important to them, we will actually duplicate that article in the space. So we'll actually just make a bunch of extra points around that article, and that pulls the centroid in that direction. And we found that that actually helps to align it with, if you're really into like Marvel movies or something, and you happen to have a couple of other movie articles that you've read, but you're really into those, then it'll pull it a little bit more there, and then the topic embedding, which I will get to in a second, will reveal the Marvel interest. I'm getting ahead of myself.
Excuse me.
Yeah.
How do you differentiate between the people who pay attention to something because they're engaged with it, and the people who watch it because they're pissed off by it?
Yeah, great question. So, so part of what I was showing before is we have the UI that asks how you feel about it. So that is a perfect opportunity to express your pissed offness, which I certainly use that emotion sometimes. We have that as well as a metric to say how important it is to you and how much you agree or disagree. So we're using these different metrics. At the moment, we haven't worked in the pissed offness, as you might say, into determining how similar users are to each other. But this is one way that we're kind of adding some color to our recommendations. Because if someone feels very happy about a subject and someone else feels angry about it, that's obviously an important thing to pay attention to.
Yeah.
Yeah. Yeah.
I know the people that watch Fox because this is.
Oh, yeah. Yeah, fair enough.
An example.
Yeah, yeah. That's a great point. These are the many questions we hope to explore and answer. Yeah. So, okay. So we've got these centroids now, each cluster. The next step is that we're actually going to embed these topics. So this goes back to what I was saying before, where you can actually take a word like music and embed it in the same space as a whole article about Ariana Grande. So we're going to do that the same way we did with the articles. And for our initial approach, we actually used a predefined list of topics. So we took about 2,000 topics that we could come up with that seemed relatively expansive and used those. Interesting side note that occurred is we actually found a little bit of a hack. So if you were to embed an article about climate change, let's say, and then embed the text climate change, those things would actually be somewhat far apart. And this is partially because the context really matters. If you're saying climate change, or pick even a single word like steak, like if the article is about steak. The relative context of that word is actually really important for where you're going to put it in embedding space. So a little hack that we've used here is when we are embedding a topic such as climate change, what we actually tell OpenAI to embed is an article about climate change. This is the world that we live in. And honestly, when you tell it that, you're actually giving it a little bit more context of like, oh, okay, that's what we're talking about, as opposed to.
We should talk. That's all that fun.
Oh yeah. Okay.
Great to go.
Okay. Cool. Yes. Let's talk. So, anyways, sharing this. We got the centroids, and now we have the topics embedded. So, fashion, handbags, leisure might be some topics at different levels of granularity, right? So, fashion is pretty coarse, and then handbags. People are into handbags. That's a very granular topic. And then the centroids, again, are the articles that people have read and rated. And we're looking at which topics are closest to those centroids. We leave a little bit of room here for ties, or close ties. So in this case, the centroid in this example is kind of in between. So we might say that this person is interested in fashion, handbags, and leisure, or maybe just fashion and handbags. But this is essentially how we can map the articles that someone has read to things that they are interested in. Okay, so now basically what we have is this vector of topics for each user of the different things that they're interested in. And it could be a binary vector, so it could be, yeah, you're pointing at the screen.
Sorry.
Yes, nobody else can see that you're pointing at the screen, but it's like right in my face.
I was just like following.
Okay, just following. So we have this vector, so we might say, okay, we detected this person, it has a centroid close to the word sports, soccer, but not basketball, right? And maybe close to politics, not the US election. And we do this for each user, and we can get this vector of the things that they're interested in. In the screenshot, we have ones and zeros. In reality, we might weight these based on how they rated the articles and things like how they felt about the article. We might also bring in things like time. So if they haven't rated an article in this subject in a little while, we might start to discount it. And then essentially what you can do is a inner product of the vectors. So it's a little computationally intensive if you want to do, every user against every other user. But if you do that, what you can get is the inner product is essentially multiplying each of these columns that you see. And the intuition behind that is we don't actually care if people have disparate interests. It's like totally fine if like one person's into fishing and one person's into video games. The things we really care about are the shared interests that people have. And specifically like the really strong shared interests. So like, I might want to find a girl who's into AI. Like that's the thing that we want our algorithm to really hone in on, is those like really strong, unique things that kind of make two people, unique as a pair. So that's why the intuition of using an inner product works, because if someone has a 0 in a topic, meaning they've rated no articles basically anywhere near this, then we're just not even going to consider it as something when comparing these two users. We then get the vector, and then you can use vector, cosine similarity distance measure to produce some kind of score that you can then show in the app. You can also use this to produce different topics that you would show in the app to the users to help them start a conversation. This is a slide just explaining how the inner product would work. It's basically like an ANDing operation, right? If there's a 0 and a 1, then it comes out as 0. And yeah, I was just explaining the intuition here. So yeah, and maybe just to reiterate, so we're talking about we really care about the union of people, we care about the intersection, this is a typo. We care about the intersection of people's interests, not the union. So we don't care about all the things that you like that you don't have in common with someone. We care about the things you do have in common. All right, let's see, we did a beta test. We had some cool results. Be a little hard to see. So we had about 40 users, including 10-ish team members. Maybe I can actually stand that.
You're setting up your...
Yeah, I was going to say, how'd that go?
Yeah. It might get a little bigger if you close out the X by the motion in the top left. Will that, yeah.
What's your success rate, I guess? What do you qualify as success?
Yeah, that's a challenging question for all dating apps.
Yes.
Yeah. I will say our CEO thought there was a bug in the system because he wasn't getting any matches, and then we lost and nobody was swiping. Everyone was swiping left. It's not a bug.
It's a feature.
Yes. Okay, well, it's a little hard to see, but these were showing the shared interests that we detected, and we found some really cool stuff. So we outed somebody on the team as a Swiftie, which is a Taylor Swift fan. So she actually matched the number of people on her interest in Taylor Swift, which none of you knew. We found out somebody had a running interest on our team. We hadn't talked about it. Abby and I actually matched on the app, which was really cool, and we matched over plant-based meat alternatives, vegan food. but that was good. So obviously these are somewhat anecdotal, right? We don't have the broad statistics here, and it is difficult to say what is the success rate. But yeah, looking at kind of the documents, all the articles that people read, and then the shared interest we were able to pull out. In general, we found some early promising results. And yeah, I think. Oh yeah, go for it.
Just like could be funny, I don't know. But I mean, if you match it, you know, you guys have matched, did you be able to find out how much the relationship, like maybe 3 months, 6 months, and then
Oh my God.
apart?
If my co-founder was here, he would like give you a hug, because this is like his vision for it. Is actually he really wants something like that, because this is actually one of the sort of downsides of a dating app is sort of like get a match and then why use the app anymore, right? Throw it away. It would be really cool if you could continue to use the app over time and see, interesting. We're like, I don't know, we're drifting apart. Why is that? We're reading too much politics. I don't know. Or we're getting closer together and we're like finding new shared interests that we have. We're like, oh, I didn't know that you were into sewing. That's a cool thing we could do together. So that's actually a really cool idea. Yeah.
Do you have an option in the app if you want to match with someone that has nothing in common with you?
See what happens.
Yeah. Opposites attract. My husband's doing business aviation. I'm not interested in aviation.
Let's see if I actually have the simulator running. Oh no, I don't have the server running. So we actually have a setting. The question was, can you choose to match with people who are unlike you? We actually have a setting in the settings tab, which is a slider, and you can choose like if you want the whole range, if you just want to focus on people who are different. Same, yes, you do have this.
I like that.
Yes, thank you. These are all of my co-founders' ideas, so I can give them credit. But glad to hear that these are interesting. Okay, cool.
I think we should let single people try it for free.
I'm getting to that. Yeah.
So some topics may be so popular, so maybe all of them you like it. We can figure out about something like a weighted, like a TF-IDM.
Yeah, that's a great point too. So the question is like, some topics are very popular, right? So as I was mentioning with my girlfriend, AI is actually not a very niche topic anymore. Maybe like several years ago. But yeah, it's a really good point. A lot of people might match on like Game of Thrones or something like that, and it's not particularly interesting to say that that's a shared interest. So it's a great point, and just kind of another thing that we want to bake into sort of the weighting of the different leads that we suggest. Yeah, I will say that we're a startup.
We don't have funding right now, but like we are looking for like amazing people with great ideas. So if you're interested.
Can I just interrupt for a second?
Yeah.
Just because we have two talks and
sorry.
if anyone has questions, I'm sure that we'll be happy to talk about it afterwards at Courthouse Social. So just we'll table until then. That's
Thank
cool.
you.
Yeah.
Okay. I will. Yeah. We have the Cuban Missile Crisis. 2 users matched on the word human missile.
That's a legitimate. What's wrong with that?
Save the questions. Save the questions.
Sorry. Okay. Anyways, there are some issues to be addressed with the topics that we had. We actually created a whole taxonomy. I'll kind of move through this a little bit. There are some scalability issues that we're looking at. As I mentioned, the n-squared computations of these lead generations are tricky. One thing we're considering is sort of a capped thing, so every minute we generate 10,000 leads, and we sort of favor the more active users initially, and then any remaining space within those 10,000 would go to the less active users. There's a lot going into that. Anyways, I will wrap that up. So yeah, we are InPress. We're trying to get the word out. We are launching August 29th, and you can sign up at InPress.app to get free access to our beta launch. So yeah. Thank you, everybody. I like the hand motion.
Thank you.
Mark's going to complain about Python.
The pressure's on, totally.
Going after a dating book.
Yeah, we're just going to get it.
Alright. Hello, everyone. Hello. How's everyone doing? It's nice to be back to the meetup. Yeah. After so long. So let me introduce myself. So for those folks that don't know me, my name is Marck Vaisman. I wear many hats. My day job is as a specialized cloud solution architect for AI at Microsoft for Azure. What that means is I work with customers and helping them use their platform for AI, ML, and data science workloads. Obviously, a lot of my time recently has been spent working with customers that are using our OpenAI service and LLMs and RAG applications and not data science work specifically, but again, nonetheless, it's part of the AI umbrella. And I'm going to talk later in the year about that separately. Today, I just wanted to do something short, fun, something that's been on my mind for a while, and it was just nice to get it on paper. So really, well, anyway, my other hats. So I also teach. I am an adjunct professor at Georgetown, teaching their Masters of Data Science, and at GW as well. And I was one of the original co-founders of Data Community DC, which is it's nice to see everyone again. It's been a long time, especially I used to run the SPDC meetup, the stickers over here, which was the original R meetup. Then we call this Statistical Programming DC, and kind of R/Python meetup, more R than Python. And I'm kind of thinking of reviving it. I just don't have time, but if you're interested, let me know. Talk to Abby, talk to me, talk to Janet, talk to Jeff. We can work something out. I was going to say something else, I completely forgot. Anyway, so this is really, if this was a movie poster, this is what it would look like. All right, this was generated with DALL-E. I tried different prompts, and what I really wanted to do is just get like the 10 things I hate about you. That 20, what is it, like 20 years old now? And do something with ARM Python. But this is, the best thing. Obviously, when you use image generation, it's generated because there are imperfections in the image, but also the writing, right? There's sort of like latent spelling errors. Generative AI cannot spell. It cannot. It really cannot. So if you see images and you see stuff like this, look at Python, right? Like that H looks like, I don't know, phi or Greek symbol. So I actually said, write or generate an image in the form or using 10 things I hate about you as the reference, and then use the R logo, use the Python logo. It didn't pick up the R logo, but it did pick up the Python logo. So anyway, and I kind of love this because it's like really reminiscent of like those 80s kind of rom-coms, right? I just dated myself. That's fine. I don't contain like my age, but that's a whole other story. All right, the abstract. So I've been working with R for a really long time, and I really never wanted to embrace Python. I didn't want to. I don't know, I just didn't. I knew it was there, and everyone talked about it, and this and that. And for a really long time, I just didn't want to deal with it. Like, I just didn't, because I really loved R and what I could do with it, and I understood it really well, and I could use it really easily, and stuff like that. But, so I work at Microsoft, and everything we do now is Python-based, right? Like, our SDKs are Python-based, a lot of our internal tools are Python-based. Microsoft did acquire Revolution Analytics many years ago, which I thought would, kind of do stuff with R. And R is still used. We still support R, not as much as I would love to, but again, so these are Mark's personal opinions. Let's just bring things with this, okay? So anyway, I was really thinking about this, and I mean, all of a sudden, like, I'm using Python more and more, and not necessarily for data science tasks, just for other things. And then when I try to do something that I know how to do really well in R, it's like, damn, this is so freaking hard. Okay? And so what I want to share with you today, and again, this is not about which one is better. It's not. We all know the answer to that, but it's not about that. And actually, if you look at, well, I do have the Python logo, but there's more R than Python on my laptop, whatever that means. It's not a talk about which one is better. I will make some fun of both, because why not? And it's really about these are just my gripes. And I'm curious, right? Because there's obviously a lot of different folks in the room that have a lot of different experience with the tools. These are tools. At the end of the day, they're a means to an end, right? And we use what we know. We use what we want to. It's great that we can use both. Nonetheless, like this is again whatever. But again, I'm not going to make this about a fight. However, this was a slide I presented at the. It was a part. I gave a talk last. Was it October? At the RGov conference, and it was titled "Rocking R with VS Code," and obviously Alex Gold from Posit was there. So I'm talking about VS Code and he's from Posit, and I just had to make a little fun of VS Code and Marck studios together. So imagine this is R and Python together, and and for those that are probably my age, you probably know the reference to this Dolly generated image.
Mike Tyson's Punch-Out?
Huh?
Mike Tyson's Punch-Out?
No, that is Rocky 4 or Rocky 3, right? Ivan Drago versus Rocky. Yeah, Rocky what, 4? 1980, okay, what? All right, so survey. So who is an R user in this room? Not a lot, oh my God. All right, I guess, what's the flip? Who's a Python user in this room? Wrong audience. Who uses both? Okay, all right. So, anyway, so for those, okay, for those Python users, have you ever used R? Yes. Yes. Okay. Okay. All right. So what I'm gonna, so I have it's not really a top 10 list. It's just a list of things that I thought about that I wanted to share with you. I have some of them I probably talk about solutions or ways I've kind of overcome the frustration, because at the end of the day you have to do stuff. But sometimes I'm just pointing some things out, and again, just in the spirit of being making some fun of us. So let's start here. Zero, negative, and open indexing. Guys, zero indexing. Oh my God! Really? Oh my God! Yes, I know zero indexing is a lot of languages are zero indexed. There was, I was trying to find the article, but I think a few months ago I read, or sometime over the last X period, I did read an article about the origins of the zero indexing, and it has something to do with punch cards and about shortcutting. It's with punch cards and requesting system hacks, or because people were using shared machines, right, kind of shared machines, and there was a way to sort of bypass the queue, and that was using something with zero. I think that, again, I need to find
It
the
also
source.
has to do with Languages Book where you have chapter 0.
With what?
You have chapter 0.
Okay, really?
Yeah.
Okay. So anyway, I don't know the why of the zero indexing. I'm not going to pretend to fix it, whatever. But but to me, why? Right? And again, not just for Python. Because data is tangible, right? Anything that we count is tangible. So a data point is a data point. The first row of a matrix or of a data frame is row number 1. It's not row 0. Oh my God!
You could implement that if you wanted to properties.
You don't have to use zero.
Also, the numbering system starts with 0.
Yeah.
Well,
It goes way back.
okay, fine, but okay. Again, I'm not going to pretend to whatever. I'm just pointing out my frustration. So when you try to do something in R, it's okay. So this is a combination of examples. It's combining indexing and array, so it's just a sequence, right? So in R, I say, okay, sequence R 1 through 5. I get a vector 1 through 5. And I want item number 3, I pull item number 3, it's number 3, and it's an integer, okay? That's easy. In Python, okay, sequence, range 1 through 5. If I print out what it is, I don't get a vector, I don't get a list, I get range object. WTF, what is a range object? So there's a lot. There's like a lot of depth in here. So in what? No what?
It's an iterator.
Let me get to that. Hold on. Okay, let me get to that.
Again, please hold your comments. And it is a good time, but it's also approaching the time when I have to leave. And you can all have a big fight across the street.
This is just slide number 2.
Oh, I know. That's why I'm here.
So anyway, you get my point. So if I print out, okay, yes, I know it's an iterator, but for that person who's using it for the first time, and you try to print out, you come to this where you type in the object and you see what it is, and it starts at 1, you come to this like, okay, I've defined a range, it's telling me it's a range, okay, I know that, but tell me what's in it. Well, to find that out, I have to iterate over it, right? Or this, or do an iterator, or a conversion to list. Like, it's not intuitive, right? Again, these are gripes. I'm not saying one is right.
Next right.
Naming conventions. So in R, right, we have libraries, you have functions. If you install a package, and again, it's just a generic library in camel case because sometimes packages have, not camel case, I'm sorry? Pascal case, because the first one is Apple, right? Camel case, yeah. So, anyway, I just made it up. But in R, when you install a package, the name of the package is the name of the package. When I load my library, it's the name of the package. If I want to find a function, it's the name of the package and my function. Guess what happens in Python?
That is pretty annoying.
So pip install scikit-learn. Great. From scikit-learn import whatever. There is no such thing as scikit-learn. And what the hell am I supposed to import? I mean, scikit-learn obviously is notorious for this. I know there's others. I couldn't think of any other one that does this. I know scikit-learn does this. Like the name of the package is different than the import name. Which okay. There are a few. It's annoying. Yes? It's annoying.
It is very annoying.
Throw that one.
Point mark.
Can we keep it valid?
Why is PyTorch torch?
Well, exactly. Other things is like modules and submodules, right? Like, okay, from sklearn import pre-processing SVM. But how the heck do I know that the other functions are in a submodule?
Yeah.
Documentation.
But it's annoying.
You're not helping. Okay? You're not helping.
You're right. Okay.
Alright. And there was something, the package names and the package names that have dashes, but that were actually used dots with names. Oh my god, that's so freaking annoying! Again.
Yes.
Viewing function source code. So, in R, you can view the source code of an object, of a function. If you type in the object, I just picked a random one, get WD, which is, list your current working directory. It shows internal. Some functions are internal, which are kind of part of R. That doesn't really print it but it shows a reference here. But then I just loaded ggplot and I, type in ggplot. Then it prints out. Again, this is an internal function. It's not probably the best example. I know, so I did some investigation. I really didn't try this, but, of course I looked online. And what's interesting about Python is, there is a Zen of Python, and it says like, what is it? Complex is better than whatever. There's one way and one way only to do something. But there's like tons of different ways to do something with Python. So which one is it? So anyway, I found this one. I just thought this was like an interesting example. But there's a package called dill, and you can actually print the source code of either like an internal or external function. In-place modifications of pandas data frames. Oh boy, I'm sure this has bitten a lot of people. All right, so in R, right, I have a data frame. Maybe I'm doing some sort of workflow, right? This is my caregiver from the left-hand side, and I have my data frame, and I remove I remove one column, which is select minus call one. Obviously, this is unique file. In pandas, if you did this, if you did the first line, and you, guess what? Nope. I mean, that's like the intuitive, right? Like, yes, Python has methods and classes and all these sorts of things. So the first one doesn't work. The first line, line number 1. Line number 3 and line number 5 do work, but in line number 3, you have to reassign it, right? I mean, kind of like you do in R. Because even though the drop is a method and it's assigned to that data frame, it doesn't really change it. Or the other trick is you can do, rather than reassign it, you can use data frame dot drop and then in place equals true, which is modify in place. So again, just little things that are annoying when you're used to doing things one way and then you try something else and you're like, why doesn't this work? It will, but I mean, obviously. Printing the contents or structure of an object. I kind of like alluded to this before, right? So back to the range object. Again, in R, I want to see what's inside an object. I can type it in. Typically, it prints it out. If it's a list, if it's a data frame, if it's a vector. You know, in R, using special objects or like classes is less common than in Python. I will give you that. They're both object-oriented, but in Python, everything's a class, everything's an object. Why? So in R, I could just type in my thing, my variable, press enter, and it just prints on screen. Or I could use str, which gives me the structure, right, of my object. And even if it's a class, it will do that. Going back to the iterator, right? So if I go back over here, I didn't actually print it over here, but yes, if I type in seqpy, it just displays range 1.5. Range 1.5. There's nothing more annoying than me trying to figure out what the hell is inside an object in Python and then just getting a pointer. It's annoying! And then I have to iterate over it, right? So again, little things. And you know, kind of like I said, like iterators, and there is no such thing like as an str. Yes, there is the dir method, or the dir whatever. And what's annoying about it is that it displays both methods and variables. Like, you know, in R, an object can have classes, or not classes, like slots, which is essentially a variable. And I think I haven't built an R class in a long time, but you use like the accent if you're using S3, S4, like the different classing, but you know, you use package X, right? And package X defines a class, it's an object, you instantiate the object. You want to pull like specific things out of that object, but you don't even know where to begin. So you do the dir, and then it shows all the possible methods, it shows all the possible variables. Well, which one is which? There's no way to tell them apart. What?
There's a keyword vars, V-A-R-S.
Okay, good, because like I said, you know, so anyway. Environment. Oh my God! Environment. Okay, so in R, let me rephrase that the way we work today is different than the way we used to work 10 years ago. Today we work in distributed systems, we work in the cloud, we're sharing objects, we're serverless. So the environment, it's like setting up your environment is really important regardless of what you're doing. I don't care which language you're using, it's important. So, but in R typically, right, you had a single R executable, you know, you probably had like 30, you know, not 30, maybe you had 100 different R packages installed in your kind of main environment, and that's the one that you use. Typically didn't cause a lot of problems. You know, dependency hell wasn't as bad when you tried upgrading a package. Sometimes you would run into issues. Let's not talk about that. You all know I'm right.
Yes.
Okay? You all know I'm right. So Python dependency environment hell management. It's not. It's like figuring out what is the because I mean, if you have a Mac, oh my God, there's like 10 different Python versions on your Mac. If you have a Windows machine, not so much. But you know, you've got the system Python. You may have Pyen, you may have Conda, you have virtual environments, and they're anyway. So yeah. RN, right? But like I said, so again, just gripes. I'm just pointing out the obvious. So what are your gripes? Those are some of mine, but I'd love to hear. You know, let's spend a minute or two. I'd love to hear others. Yes.
Python doesn't tell you that it does shallow copies.
That does what?
That it does shallow copies.
What does that mean?
It copies pointers, it doesn't copy values.
Okay. Copy. Right. So right in R, it's
Like
copy by.
you can do pass by reference and you don't even know you're doing it.
Okay.
Yeah. I found that out like
You can alias really easily.
Okay. What else? Any other gripes? Yes.
R makes you like to select always overridden by any package that you import.
Yes, that is. Agreed. Okay. Yes.
I would say Python, one of my pet peeves is that if you use a mutable object as the default argument, then it like is one global instance of it. So then if you modify it in the function, like it's always going to be changing that one thing. Like if your default is a dictionary, then only one dictionary is going to exist for all the use of that function. It's not going to be a different dictionary every time you call it. And I've been bitten by that one like multiple times. It sucks.
Yes. Indentation. I mean, that's okay. All right. Well, that's a whole other question. Is it them or emacs? Come on. All right, cool. So, you know, in the spirit of, again, we started punching each other. Now let's talk about, you know, what are some nice things about one that may not be available in the other. So, these are some things that I think are actually cool about Python that are not necessarily available in R. When I say not necessarily, it doesn't mean it's not there. There could be some sort of implementation. But one thing I found really cool is the way you can use underscores. And I actually learned this recently. I didn't know this. It's really helpful for like writing large numbers. So you know that's what 10. Whatever how many zeros that is, I have no idea, but it's like, you can at least count the zeros. And you can do this not just in decimal, you can do this in like, in other base, which is, I think is actually a really cool thing. Returning multiple values from a function at once. I think that is actually useful. Now, before using R, I used to use MATLAB. MATLAB did that. R doesn't. But one of the things that I learned for me, for R was natural was coming from a vectorized. I haven't talked about vectorization. I'm not even going to talk about that today. But anyway, and dictionaries. I mean, R has lists, and you can do named lists, but it's not really a dictionary. And I think dictionaries can be useful in themselves. So you see, like, I'm actually trying to get some love here. Some cool things about R that are not necessarily available in Python. So typically in the R world, you're going to get, like, you know, the statistical packages, right, like out of the box. You're going to get that first. I think the statistical ecosystem in Python, it can't match the one in R. So I think that's the point for R here. RStudio, you know, as an IDE, I've always loved RStudio. I thought it was an amazing, I still think it's an amazing IDE. There has never been anything like it for Python. Well, yes, RStudio, I guess now supports Python. What? I get to that one.
Yes, Spider. Yes, Spider.
Spider. Tidyverse, okay, I know there's going to be haters about the Tidyverse. That's fine. I love the Tidyverse. I think it makes sense. You know, there have been some implementations in Python. I personally never use them, but again, and then I think, you know, in R, like the non-standard evaluation obviously is what allows for the tidyverse and that sort of thing. It just makes it easy, right? Like you don't have to, but like when you look at Pandas syntax, it's very, to me, it's very reminiscent of like traditional R syntax, right? Where you have to say like df whatever equals df and square brackets. Like it's very close to that, but when you move into the tidyverse, it makes syntax a lot simpler. And I think the syntax, the tidyverse syntax can't beat anything for data work. Some cool things that R has adopted from Python, and these are actually things that I use. So there's an opparse package, which is modeled after the Python argparse, which parses command line inputs in a shell script. You can use double dash. Otherwise, you just give it the parameters like in text. It's still text, but you just do like space. Header HTTR2 is really modeled after the request package for REST API access, HTTP methods. And then, you know, RM, right? RM sort of came to be because there's also a need to have virtual environments, you know, going back to this idea that in today's world, having virtual environments, regardless of what tool you're using, is important. So RM, I think it's not perfect, but it actually makes things a lot easier. And I'm actually using, so now on when I create a new project, I create a Python virtual environment and I create an RM because I only have the packages that I need for whatever I'm doing, and I don't have these massive dependency issues. Cool things that Python has adopted from R. So Plot9, which is the ggplot implementation. Ciuba, I don't know if that's pronounced. I've never used it, but I know it's like an attempt to reproduce the tidyverse data frame stuff. And then PyJanitor. So Janitor package in, I don't know, I think it started with R and it got ported to Python, if I'm not mistaken. I don't remember this one. Janitor is a great package, you know, for doing name cleaning and data cleaning. It's just really, really cool. You know, the R version is just called Janitor. And, you know, obviously working, so I'm just going to close here kind of with working with both, right? Because at the end of the day, Again, I'm using Python for non-data science tasks a lot more these days, not necessarily data stuff. For data stuff, I tend to go to R because I know it. But if there was a way where I can actually work on both together at the same time, I've been like thinking about this, exploring it. I don't have a good answer, but I think having using polars, which is the, have you folks heard of polars? Does anyone know what polars is? Okay, raise your hand if you have heard of polars. Okay, not a lot of you do. For the rest of the audience, polars is a relatively new project. I don't remember who created it, but it's essentially a data frame implementation written in Rust. It's very fast, it's very powerful, and it has both R and Python APIs. And it actually uses an Apache Arrow backend. And for those that don't know, right, this is like Apache Arrow and Apache Parquet. Obviously, Apache Parquet is a way to represent, file format on disk. Apache Arrow is to do it in memory. And positron. Have you folks heard of positron? Who's heard of positron? Okay, only a few. Positron. This is something brand new from Posit. So they forked VS Code, and they created. They just released this. They actually, well, they've been working on this for a while, but they actually have now. They have an open beta. It's available on GitHub, and I've been playing with it a little bit. And essentially, what you get is it's a fork on VS Code. It works, there's a lot of VS Code in there if you've been using VS Code, which I have been using now for a long time for both R and Python. The R extension for VS Code gets you enough, but it's not, there's still a lot missing. And interestingly, I was at the New York RR conference a couple of weeks ago. What was it, in May? Yeah, it was in May. And I was sitting in the auditorium, and Hadley was sitting like 2 rows in front of me, and I see him typing on his Mac, and I see something that looks like VS Code. And I come up and he's like, Hadley, are you using? Because if he was using VS Code, I wanted to know what he was doing, because, I mean, obviously VS Code is a Microsoft product, but regardless, I've also been using VS Code because as an editor, I mean, VS Code is a lot more than an editor, right? But we have a lot of integrations with VS Code, but because if you're doing stuff together, it makes sense to have a single IDE to do both, not 2 separate IDEs. Anyway, long story short is, I asked him, like, Hadley, are you using VS Code? And he just looks at me and he's like, maybe. And then I talked to him a few weeks ago, and he told me about Positron, and they actually just launched the open beta last week or 2 weeks ago. And it's really cool because you get first-party support for R and Python, and so it looks like VS Code, right, at the end of the day, and I can do a console. So I can start an R console, I can start a Python console together, I can have, I'll be happy to show this to you, but I just wanted to bring it up because I think it's a step in the right direction. It's still beta, there's still a lot of issues with it. There's obviously there's the issues list and whatever, but nonetheless, I highly encourage you to check it out. It's not a replacement for RStudio. I don't, as I asked them, they're not gonna forego RStudio in the near future. I don't think so. But it's a great step because in the IDE world, the only way you can really do interactive sessions in Python was through Jupyter. It still uses Jupyter, I think, as a backend, but the interface is just cleaner, right? Like you can do control, command return, the same in R and Python. So the muscle memory that you have from one language works to the other. It's annoying to have to do this separately. Anyway, I just wanted to point this out. I think it's awesome. And that's it. So thank you for your attention. We can pass it out at the bar.
That's right.